Previously, we solved a system equation with 3 letters and 3 unknowns, and we noticed we can use x to remove the 2x and 3x, so multiply them by the second equation by appropriate numbers to remove the x, and then we add the equations, and we got 2 equations without x. We group these 2 equations together, then we can eliminate a z by multiply equation 4 add 5 minus 3. Now I get rid of a z, I get y equal to 2. So then you can put 2 back into equation 4 to give what z is. Then you can put y and z back to equation 2 to give what x is. And so in this process, we notice if we write out the x, y, z over and over again. And so we can simplify more by using matrices. What's matrix? A matrix is just using the table, just a table of numbers. I can easily convert a system equation into a matrix form by extracting the coefficient 1, 4, minus 7 for the x, y, and the numbers. And each equation corresponds to a row, and each row corresponds to an equation. So back and forth, it's easy to translate. And we're going to use the matrix to keep tracks and using these operations and to manipulate them. And the first operation is switching 2 rows of a matrix. And here, if I switch the first and second row, I get this new matrix. And the second operations I might apply is multiply a row by a number. In this case, the second row multiplied by minus 3. Then I get a new matrix. And then the third step is I can multiply a row by a number that add to another row. So in this case, multiply the first row by minus 2. Then take that add to this second row and add one of a new matrix. The point here is all these new matrix correspond to systems that have exactly the same solution as before, the system. They don't change the solutions. So we're going to use row operations and manipulate a matrix. And to what end? And this is why elimination says, okay, and you put the system into a matrix that use the row operations to manipulate until all these positions are become zeros. And then you go backward to solve the systems. Here we go. We'll put this matrix into the system into a matrix. And first we notice is we do it by hand. It's easier if I put the 1 up there. So I switch the first 2 rows. Then I multiply the first row by appropriate numbers to make this 0, make this 0, the 2 steps here. And then we'll make the last one 0. Then we solve it backward. I can get z, I can get y, I can get x. Then the problem is done. Okay, and that's the matrix method. Bye-bye.